These are the guided notes for completing the square. Try the warm-up activity and see what you notice. We've got 4 problems here: x squared plus 8x plus 16, x squared minus 18x plus 81, x squared plus 2x plus 1, and x squared minus 10x plus 25. And you're welcome to stop the video for a minute to go ahead and try these problems. Remember, you're looking for 2 problems that multiply to get the last term, and those same 2 numbers have to add up to get the middle term. So I'll give you a moment, and then if you were able to figure those out, then start the video again. Okay, one of the things I hope that you notice is that because this number is positive, that means those numbers have to have the same sign, and they're both going to be positive. So they would actually factor into, or this expression would factor into x plus 4 times x plus 4, or another way of writing it would simply be x plus 4 squared. Over here we have 81. So 2 numbers that would multiply to get 81 being the same sign, although when you add them together it's obvious that they both have to be negative because this is a negative 18, will be x minus 9 times x minus 9, or x minus 9 squared. And then the last 2, we have x squared plus 2x plus 1, 2 numbers that multiply with the same sign. Those signs have to be positive. Then we to multiply to get 1, but then add to get 2. That would just simply be x plus 1 times x plus 1, or x plus 1 to raise to the power of 2. That's a little bit easier way of writing the problem. And then last but not least, when you're factoring x squared minus 10x plus 25, again, looking for 2 numbers with the same sign. In this case, they both have to be negative and add up to 10. Multiply to get 25. That answer would be 5. So x minus 5 times x minus 5, or simply x minus 5 squared. Every single one of these problems where you're writing the same binomial twice are called perfect square trinomials. So these 4 expressions, are all perfect square trinomials. So they all result in a binomial that's squared or raised to the power of 2. So today we're going to find out why perfect square trinomials are so important in completing the square. So let's actually practice creating one. So to create one, we're going to divide our coefficient of x, meaning the middle term, by 2 and square it. So b divided by 2 squared. And we're going to replace the letter c with that result. And when we do that, then we're going to turn around and create a binomial squared. So let's do one of these so this makes a little bit more sense. So we're going to take not the x squared term, but the middle term, 14, divided by 2. That gives us 7. 7 squared is 49. That's 7 times 7. That's 49. So c is going to get replaced by 49. So now we have x squared plus 14x plus 49. All right, now, next what we're going to do is we're going to do the same thing we did above with the warm-ups. We're going to factor this problem. So we're looking for 2 numbers with the same sign that multiply to get 49. And we add them together, we get 14. That'll be x plus 7 and x plus 7, or x plus 7 squared. I want you to notice a couple of things. 49, the number that we divided by 2 and squared, ends up being the constant term. That creates what's called a perfect square trinomial again. And then the 7, that's the number, the middle term that we divide by 2, that actually ends up being the factor x plus 7 and x plus 7. So that's always going to be the case. And let's look at some more examples so this starts to make sense. So here I'm solving for c. I'm trying to create a perfect square trinomial. I do that by taking the middle term, 8, dividing by 2, that gives me 4, and squaring this 4, and that gives me 16. So it's going to become x squared plus 8x. We're going to replace the c with 16. Now we're going to turn around and factor this expression. This is a perfect square trinomial. So I'm looking for 2 numbers that multiply to get 16, add to get 8. They have the same sign, and both signs should be positive. So that should be x plus 4 times x plus 4, or x plus 4 squared. And then once again, please notice that after I divide the 8 by 2, that same number is the number that ends up in each of our factors. Okay, let's look at another example. I've got x squared minus 2x plus c. I'm going to take the negative 2x, divide it by 2 and get negative 1, square that term. Negative 1 times negative 1 is a positive 1. So we get x squared minus 2x plus 1. And so two numbers that multiply to get 1, but when I add them together I get a negative 2, are going to be x minus 1 times x minus 1. So once again, notice negative 2 divided by 2 is negative 1. And that's the number that ends up in each of these factors. So we end up with an x minus 1 squared. Last but not least, this time I have an odd number. We've had even numbers up to this point, 14, 8, and 2, but this one's an odd number, so this problem is going to be slightly different. We're going to divide negative 9 by 2, but when we do, it doesn't divide evenly, so we're going to have to leave it as a fraction. So when we square it, we're going to get 81 over 4. So negative 9 times negative 9 is 81. 2 times 2 is 4. So we're going to add 81 over 4. So it'll be x squared minus 9x plus 81 over 4. And again, going back, we're looking for two numbers with the same sign that multiply to get 81 over 4. However, when we add them together, we get a negative 9. So the numbers both need to be negative. So once again, let's look at what's in the parentheses that we're about to raise to the power of 2, negative 9 over 2. So it's this term that ends up being inside each of our factors. So it'll be 9 minus 9 over 2, x minus 9 over 2 and x minus 9 over 2. And because this term is negative, this is negative, and so are our factors. So, and then again, you could write the same factor one time, x minus 9 over 2 raised to the power of 2 to get that result. So every single one of these we generated is a perfect square trinomial, and then we factored each of those perfect square trinomials. So that leads me into the steps for completing the square. In order to complete the square, what you need to do is you need to have a perfect square trinomial on one side of your equation. Most of the time that doesn't occur naturally. So you're actually going to create the perfect square trinomial. And then what you're going to do is take the square root of both sides of your equation to solve the problem. So these steps are outlined here, but we're going to go ahead and do them together. This is one of those methods that's good to try besides using the quadratic formula if you cannot factor the quadratic equation into the product of two binomials. So if you're looking at it and you can't think of two numbers that would multiply to get the last term but combine or add together to get the middle term, two options are to use the quadratic formula, which we'll talk about on another day, or to complete the square. So let's go through a first example. We've got x squared plus 14x plus 24 equals 0. This is not a perfect square trinomial. So we're going to go ahead and move the negative 24. We're always going to move the last term over to the other side of the equal sign. So we'll get x squared plus 14x on the left side and equal to negative 24 on the right. We're going to leave a blank space here for that perfect square trinomial that we're going to create. Do you remember how we do that? We're going to take 14 divided by 2. That gives us 7. We're going to square that 7 and get 49. So we'll have x squared plus 14x, and we're going to add 49 to create a perfect square trinomial to the left side. That means we also have to add it to the right side of the equation because of the equal sign in between. So the next step is to go ahead to factor the left side. On the right side, we're going to combine like terms. So again, looking for two numbers both with the same sign that multiply to get 49, and when we add them, we get 14. They're both going to be positive because this sign is positive. We'll get x plus 7 times x plus 7, or simply x plus 7 squared, and negative 24 plus 49 is 25. Now that we have everything squared, again, creating the perfect square trinomial, we're doing all this for a reason. We can simply take the square root of the left side, which means we'd have to take the square root of the right side of our equation. So we'll end up with the square root of x plus 7 squared equal to the square root of 25. When we do that, the square root cancels out the squared term, and we're left with x plus 7 on the left equals on the right plus or minus 5. So to solve this problem, we're going to create two cases. X plus 7 equals a negative 5 and x plus 7 equals a positive 5. Now you can write it the other way around if you want. You can write x plus 7 equals a positive 5, x plus 7 equals a negative 5. There's nothing wrong with that. But you can't change the sign of the 7. You must change the sign of the 5. So we're going to subtract 7 from both sides. So we get x equals over here negative 12. When we subtract 7 over here, because the 5 is positive, we get x equals negative 2. So we've got two solutions and we're done. Let's try this again. So first step, we've got x squared minus 10x plus 7, which you'll probably recognize there's not two numbers that you could multiply to get 7 and take those same numbers and combine them to get a negative 10. So in that case, 7 is prime, so the only two numbers that multiply to get 7 are 7 and 1. So we're going to complete the square to solve this problem. So we'll go ahead and subtract 7 from both sides. So we end up with x squared minus 10x equals a negative 7. We're going to take that middle term, and we're saving space here to create that perfect square trinomial. We're going to take that middle term, negative 10, divide it by 2, and square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is a positive 25. So negative 5 times negative 5 means the negative signs will cancel out, and 5 times 5 is simply 25. So we're going to add 25 to the left side of the equal sign and also to the right side of the equal sign. So we'll end up with x squared minus 10x plus 25, a perfect square trinomial, and on the right side, negative 7 plus 25. Now, looking for two numbers with the same sign that multiply to get 25, and when we add them together, we have to get a negative 10, so they both need to be negative. That'll be x minus 5 times x minus 5, or simply x minus 5 squared. And then negative 7 plus 25 is 18. Again, we'll take the square root of both sides because we're solving for x, and right now we can't find x because it's trapped inside the parentheses that are raised to the power of 2. So I need to get rid of that power of 2. So we square root each side. The square root of x minus 5 squared is just the square root, and the 2 cancel out, and we're just left with the x minus 5. Over here on the right side, we're left with plus or minus the square root of 18. Now hopefully you notice that 18, it's not a perfect square, but we can break it down into 9 times 2, with 9 being the perfect square. So we end up with x minus 5 equals plus or minus the square root of 9 times the square root of 2. The square root of 9 is 3, so the 3 comes out from underneath the radical, and we'll end up with x minus 5 plus or minus 3 times the square root of 2. We move the 5 over to the other side. You can't leave it as is because we're solving for x, so we're going to add 5 to both sides, and we end up with x equals 5 plus or minus 3 times the square root of 2. Because this is a radical, we cannot combine it with the 5. It doesn't become 8. It doesn't become or 2 times the square root of 2. We just have to leave it as is. A radical and a regular real number or integer don't get combined. So we're going to leave them just separately together. You could have also written this problem as x equals 5 minus 3 times the square root of 2, and x equals 5 plus 3 times the square root of 2. That would have worked as well. Let me scooch that up and see it a little bit better. And that would have worked as 2. Okay, let's go on to the next problem. So now, let me say one thing real quick. So all of these problems that we're dealing with have an x squared in the front. That's very important. So completing the square requires that the x squared term have a 1 in front of it. If it doesn't, you have to either factor out a GCF or divide all the terms by whatever the number is that happens to be in front of the x squared term. So that can make things tricky or complicated, especially if you end up with a fraction as for the middle term, which we've already seen. Okay, so that's not the situation here, so let's go ahead and get started with this example. I've got x squared minus 4x minus 8 equals negative 16. So I'm going to move the 8 over to the other side. This is not a perfect square trinomial, and I need to create a perfect square trinomial. So when I add 8 to both sides, I'm left with x squared minus 4x, an empty space here where the negative 8 was, because the 8's cancel out, and I'm left with negative 16 over 8 over here, which gives me a negative 8. Once again, we'll take that middle term, negative 4, divided by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm going to add 4 to the left side and the right side of the equation. So we'll end up with x squared minus 4x plus 4, a perfect square trinomial. And on the right side, negative 8 plus 4. So I'm looking for two numbers with the same sign that multiply to get 4. Those same numbers, when I add them, give me a negative 4. So they're both going to have to be negative. So we're going to end up with x minus 2 squared. And over here, negative 8 plus 4 is simply negative 4. We're going to do the same thing again, square root both sides to get rid of the power of 2. So when we square root x minus 2 squared, these cancel, and we're just left with x minus 2. Over on the right side, when I take the square root of negative 4, well, that's going to break down, right? Hopefully we recognize that we can separate on the right side. This will become x minus 2 plus or minus the square root of, let's break that 4 and that negative 2 out into two separate numbers. And then we can break it out even further and take the square root of 4 and the square root of negative 1. The square root of 4 we know is 2, and hopefully we recognize that the square root, let me scooch this up, of negative 1 is I. So that's something we learned when we studied about the imaginary numbers and complex numbers. So the square root of negative 1 is I, so we can go ahead and replace the square root of negative 1 with I. So they're multiplied together, so we just end up with x minus 2. We haven't done anything to this left side just yet, equals plus or minus 2i. We'll add 2 to both sides, and we get x equals 2 plus or minus 2i. Now, we can't combine these. This is a real, and this is an imaginary part. So we're going to leave them as is. You could have also written this problem, or the solution, as 2 minus 2i and 2 plus 2i. All right. Next step, I've got x times x plus 8 equals 5. So to get started here, the first thing I have to do is go ahead and distribute that x to get rid of these parentheses. So x times x is x squared. X times 8 is 8x. We've already got the 5 on the other side of the equal sign, so we're just going to go ahead and leave that there and get started. We're going to jump to the step where we take 8 divided by 2 to get 4, and then square it and get 16. 4 times 4 is 16. So we're going to add 16 to the left and the right side of the equations. We're doing that so we create a perfect square trinomial over here on the left side. Over here, we're just going to simply combine like terms. So two numbers that multiply to get 16 each being the same sign, and then when we add them, we get a positive 8, so they both have to be positive. Means that we're going to end up putting a plus 4, x plus 4 squared over here for our factors. It's x plus 4 times x plus 4. 4 times 4 multiplied equals 16. 4 plus 4 added together gives us 8. And over here, when we combine 5 plus 16, we get 21. Now we're going to take the square roots of both sides. So the square root of x plus 4 squared is simply x plus 4. The square root of 21 is plus or minus the square root of 21. We're going to subtract 4 from both sides, and we get x equals a negative 4 plus or minus the square root of 21. And then once again, since this number is an integer and this is a radical, we are not going to combine them. 21 is prime, so we're not going to be able to simplify that. It breaks down to 1 and 21 or 3 and 7. And so we don't have a perfect square in 21, so we're just going to simply leave it as is. Okay, so now this gets us to the part where a does not equal 1. So our first choice always is to see if we can figure out a GCF. So we have 3x squared plus 12x plus 15 equals 0. So my first thought is, can I factor out a 3 out of all of these terms so that I end up with an x squared with a 1 in front of it as its coefficient? So we have to do that, otherwise we can't take the next step to complete the square. So if we divide the 3 into each of these terms, we can simplify them. 3 divided by 3 is 1, so we get 1x squared. 12 divided by 3 is 4, so we get 4x. 15 divided by 3 is 5, so we get, and then 0 divided by 3 is 0. So we get x squared plus 4x plus 5 equals 0. So we're going to move or subtract the 5 and move it to the other side of the equal sign, and we're actually going to drop the 3 at this point. So The 3 actually isn't going to affect the completing of the square portion, so we can actually, I want to say, throw it away because that's the easiest way to express what we're going to do, but we're really not. We're just temporarily dropping it because we don't need it to solve the problem. We need it for the factoring piece, but we don't need it to solve the problem. So what we're going to do is subtract 5, move it to the other side of the equal sign. So we're left with x squared plus 4x equals negative 5. And again, we're going to create that perfect square trinomial over here on the left. So we'll take 4 divided by 2. That gives us 2. 2 squared is 4. So we're going to take x squared plus 4x and add 4 to the left and right side of the equation. That gives us x squared plus 4x plus 4, a perfect square trinomial over here on the left side of the equal sign. And negative 5 plus 4 combine to give you a negative 1 when we combine our like terms on the right side. Let's go ahead and factor the left side, looking for two numbers that multiply to get 4. They have to be the same sign. We add them together, we have to get a positive 4, so they're both going to be positive. And again, looking up here will help us get our term if we don't figure it out right away. It'll be x plus 2 times x plus 2, or x plus 2 squared. So then we'll go ahead, and to figure out what x is, we need to get rid of the power of 2. So we take the square root of both sides. So the square root of x plus 2 squared, the square root cancels out the square term, and we're left with x plus 2 over here on the left equals, and the square root of negative 1 is plus or minus I. So negative 2, moving the 2 over to the other side, we get negative 2 plus or minus I. So x equals negative 2 plus or minus I. And again, this is imaginary and this is real, so we're going to leave both parts as is and not combine them. All right, so let's look at the next problem, number 14. We've got 6x plus, in parentheses, x plus 2 equals negative 42. First, we want to get rid of those parentheses, so let's go ahead and distribute. So we're going to multiply 6x times x and 6x times 2. So we'll get 6x squared plus 12x equals 42. Then next, because there's a 6 in front, let's go ahead and divide each of these terms by 6 and see if we can factor out a GCF of 6. So when we factor out the 6, we're left with x squared. 6 divided by 6 is x squared. 12 divided by 6 is 2x. And negative 42 divided by 6 is negative 7. So we're going to take that 6 and put it aside because we're solving here. So if we were simply finding the factors, we need to bring it down here and write the 6 here, just like we would probably need to write the 3 down here. But we're not factoring here. We're using the method of completing the square to actually find the solutions. So what are we going to do? We've got x squared plus 2x equals negative 7. We're going to take the 2, divide it by 2. That gives us 1. Then we're going to square the 1, and that gives us 1 times 1 is just 1. So we will add 1 to both sides of the equal sign. So x squared plus 2x plus 1 equals negative 7 plus 1. So we're looking for two numbers that multiply to get 1. They're both going to have the same sign, and when you add them together, you get a positive 2, so they're both going to be positive. So that's going to be x plus 1. 1 times 1 equals 1. 1 plus 1 equals 2. So we could write it as x plus 1 times x plus 1, but it's easier just to write x plus 1 squared. And again, if you're stuck on this side with the factoring, you can get the 1. This is a positive 1, so it's just going to be x plus 1 inside these parentheses. And then negative 7 plus 1 is negative 6. And again, we need to get rid of the power of 2, so we square root both sides. So we square root x plus 1 squared, and the squared term and the squared root and the squared term cancel out, and we're left with x plus 1. Over here on the right side, we end up with plus or minus the square root of negative x. We can break negative x down into 6 and negative 1. And then notice that the square root of negative 1, we said this before, is I. So the I is going to come out, but the square root of 6 will stay underneath the radical. You can break 6 down into 1 and 6 or 2 and 3. None of those numbers are perfect squares. So there's no perfect square that we can take out of the 6. So it'll end up with plus or minus I times the square root of 6 with the I going in front. And remember, the radical is always last. Now we still, over on the left side, have x plus 1. We haven't done anything with that yet, but we do need to get the x by itself. So we'll subtract 1 from both sides. and we end up with x equals -1 plus or minus I times the square root of 6. Keep in mind this is real, this part's imaginary, so we can't combine them. All right, the very last problem I want us to look at, which I think is just kind of cool, is we're going to take, there we go. We're going to take an equation written in standard form, y equals x squared minus 8x plus 9. And we're going to actually change this expression in standard form into vertex form. How cool would that have been when we were graphing if we could rewrite our equations in standard form into vertex form to get our vertex very easily? So let me show you how you do that. You actually do that with completing the square. This one's going to be a little trickier. We have a y value here, which in our previous problems we didn't have a y, and we're not moving the 9 to the other side of the equal sign. Remember before we would have said subtract that 9, move it to the opposite side of the equal sign. We're actually going to leave it over on the same side as everything else. But the process besides that is going to be very similar. So we've got x squared minus 8x. This is not a perfect square trinomial. So I'm going to create a perfect square trinomial. There aren't two numbers that multiply to get 9 and those same two numbers. They have to be the same sign because 9 is positive, would give us a -8. So this is not a perfect square trinomial, so we're going to create a perfect square trinomial. So we're going to take the middle term, the number in front of the x, divide it by 2, so -8 divided by 2 is a -4. We square that -4 and we get 16. So we're going to add 16 to this expression, x squared minus 8x plus 16. But we also, normally we would have added 16 to the other side of the equal sign and combine it with our 9, which should be on the other side of the equal sign. But we're going to leave both of those numbers over here on the right side. That means if we add 16 to the left side, we also have to subtract 16 to the left side so we don't change anything. So when we do that, we end up with x squared minus 8x plus 16. We can combine 9 and -16 and get -7. Hopefully you recognize that this is a perfect square trinomial. I put parentheses around these three terms just to sort of emphasize the fact that they can be factored, but not with the 9 and the -16. So when we factor these, we're looking for two numbers that multiply to get 16, both with the same sign, and when you combine them, you have to get a -8. So they both have to be negative. So that would be x minus 4 raised to the power of 2, or x minus 4 squared. The 9 and the -16 give us a -7. So I end up with x minus 4 squared. And again, if you're looking for what factor or what number goes in here, you can get a clue from -8 divided by 2 is -4. So that's the number that's going to end up in here inside the parentheses. So x minus 4 squared minus 7. So that gives us a vertex of 4 and -7. Remember, it's opposite h, but keep k value as is. And we're done. So I thought that was neat to be able to see that. Anyway, have a good day and good luck with the assignment.